Good morning, guys. The core meeting is going a little over, so hopefully folks from there should join soon, but we'll give them a little extra time to join. Matt, I see you listed twice, so you must be extra dedicated to joining this meeting.
I joined once. I'm dual joined to another meeting, but this was because I realized that I tried to set my mic off and close the call, so it's going to drop it. Blue Jeans will forget my other instance soon.
It just dropped. Hey Matt, how's Beast going?
It is making progress. Beast's work has moved. Focus has moved to work by Adam Emerson to put Beast compatible AIO interfaces into Liberados.
Nice.
And that's going on.
I have to say that I'm really excited for Beast. I hopefully I'm not putting too many expectations on you guys, but I'm super excited about it.
Progress. Definitely progress.
It feels like the thing that we should, that we've wanted for like nearly a decade. So I'm very excited. I'm glad to see you guys doing so much work on that.
Well, we should add you. We'll draw your attention to the PRs by Adam, so you can help review maybe what we're trying to do. We're trying to do the interfaces there, and there's going to be plenty of issues that I think that to be resolved to keep compatibility with Liberados applications.
Yeah, I mean, you guys, you're all kind of at the forefront of all of the work that's been going on with C-Star and that whole kind of model anyway. So I think I don't know how much I can add beyond what you already know, but it seems like you guys are going in the right direction with a lot of this kind of stuff. So good job.
All right. Okay, we can just go through these pull requests quickly. The first one is the RocksDB one. Mark, you guys were just talking about that, but I was tuned out to start by something else. What's the deal there?
So my Josh, I guess, isn't here, but my personal take on this is I don't think it really matters that much. I mean, I think it maybe is going to marginally help in situations where you end up with a bunch of like stale stuff in a high level that you don't really need stuff to be in. It could be in like level 3, even though it's stuck in like level 4 for a while. So you get some additional write amplification. I don't know. I could be totally wrong, but I kind of question if it's really going to make a big difference one way or the other.
Yeah. It's not going to hurt, presumably, though, right?
Josh found something in the header that said that it could like produce like suboptimal LSM trees or something, but they didn't elaborate any farther than that. So I don't know. Who knows? Maybe, but for the monitor, I don't think it really matters. If it helps, or if it even gives the perception of helping, then sure, whatever, it's fine. I would be more hesitant to apply it to the OSD unless we actually like go through and make sure it's not doing anything bad. But
all right,
that's my take.
Okay, let's see. Adam closed a couple of his hash pull requests. The one that's still open, I commented on. I think there's one extra hash call that he's making that's not necessary, so we can simplify it slightly. But we'll see. Let's see. Another one that was, those are all closed. On the Blue Store one, Kifu's testing it. Looks like they fixed the perf counters to use the right clock resolution. Mark, your priority cache one is ready to test now too. Oh, good. And Kifu has it in his testing branch. Igor's bitmap allocator, I ran it through and it failed a unit test. So I'm not sure if he's revised it yet or investigated, but there's that. Just
Did
figuring
the
that one.
unit test failure, did that like make sense? Was it like a when you expect to fail due to something like this?
I didn't look at it closely, but it failed calling it was initializing the in-memory allocator state during startup, during mount.
Okay.
So it was like in the updated code where it crashed. So I think
one thing I would like to bring up with my PR is that it was failing these Ceph disk tests, and I have no idea why, and I still have no idea why the changes I made actually fix that. Like it's now passing the make check, and I don't know why. I mean, I know I fixed a bug that was like a really weird corner case bug that I spotted after seeing those, but I have no idea why it fixed it.
Yeah, those tests have always been fragile. So I look forward to Alfredo ripping out the set disk tests.
Yeah.
They're super annoying. Yep. All right. librd supporting throttling. I'm not sure who's reviewing that. That probably isn't Jason's, but I think he's out right now though. The Adam review to BlueOFS stuff I've changed. I haven't looked at this one yet, but it looks like he liked it. So that's good. Guess I'll mark it as needs QA. And the IO throttler, Eric extracted. Has he finished extracting? Eric is planning on extracting this out from all the other DM clock stuff. He's not done yet. Dun, dun, dun. Okay.
Oh, no.
That's it.
No, I can't prod him.
Okay. Yeah, it's on a last update I heard a couple days ago. He was close, I think so. Or making good progress at least. That's good. Let's see, the huge table one looks like Braddock has cleaned it up a bit and it's ready for review. Maybe Adam wants to look at that one too. Oh, Kim. Let's see, there's a crypto cleanups thing from Kifu that needs some fixes. Ongoing optimization stop tracker from Bretislav, that looked quite promising. I'm not sure what the current status is there. It needs a rebase at least. Is he talking to, yeah, Peter, okay. Anyway. Okay, lively discussion, yes. Periodic discard, that one's no movement. Yeah, these other ones have no movement, so that's about it. All right. We don't have a lot on the list here except OSD memory usage. What's that?
Oh, that's just me making the assertion that someday we'll be able to say, here's how much memory the OSD should use and try to stick to it.
Yep.
So
yep.
yeah, all of this memory like work that in the last like week or two that I've been looking at of how much memory we use, and then also kind of this work towards dynamically adjusting memory use or memory pool assignments based on priorities. I think all of it kind of confluates into this storm of, really what we want is to say,
yeah,
try to stick to this. I don't think we can guarantee it, but we can at least say try to stick to this memory usage, kind of adjust things to decrease until we're close to that memory usage or right around it, and then, do our best. I think we can do that though. I think we've maybe got enough data to be able to say, here's what we want to target. We're keeping track of everything. We're keeping track of high priority items and lower priority items. We can dynamically assign things to try to hit this target. I think that's possible. So I want to work towards at least attempting it.
Yep, I think that makes sense. Yep, I think that the one, eventually there's going to be a point where we add a configuration option that's like OSD memory, and then everything else sort of is subsumed by that. But we're not. I don't think we're there yet. We don't have enough pieces in place. The one thing that I think in the short term we do need, that I was planning on doing directly on top of your pull request as soon as it merges, is just the like adjust based on the observed overhead that the allocator seems to be adding in. And I'm not sure how to do that yet. I went and looked a little bit to try to get the stats from the allocator, and I couldn't find them to compare like the amount that the allocator thinks it's allocated versus how much it's used from the operating system. So scale. But
did when you were looking, is the same stats that we get in the perf dump for the heap allocation, is that not good enough?
Stats we get in the perf dump.
Sorry, the heap profile.
I tried to avoid the heap profile because I thought that was an optional thing that we wouldn't want to turn on.
Probably.
And so the interfaces I found were malinfo and I can't remember what the other one is. Like, user include tc malloc perf. Each. It's basically there's a mal stats, tc malloc stats, which prints everything to standard out, so it's completely useless. And there's a tc malinfo, which returns this malinfo structure, which has like 10 fields with like really confusing names. And then if I remember correctly, there's this comment that says it's only for arena 0. And there are like 50 arenas or something like that. So yeah. As far as I could tell, it was like completely and utterly useless.
I mean, one option that
there's a tc malloc size, which is equivalent to malloc usable size, but I don't know. Yeah, I don't know. I'm not sure what the right interface is here.
One option that we have is, given that already for the cache balancing, we do this on a really coarse basis. It might not be terrible to just grab a heap profile every 5 seconds or whatever, right? And then use that to figure out if we're close.
I thought that if you turn on the heap profiling, it adds all this overhead of, because it has to do all this accounting for all the allocations.
Yep.
So if you turn it on, like to make one call and then turn it off again, like does that actually do anything useful?
If we know what the total allocation size is, I mean, that's really what we're going for, right? We don't care about how much any individual thing is affecting things. We really just want to know how much is allocated. I don't even know how it calculates that right now. Like when you dump it, I don't know where it's getting that from.
Yeah. Maybe we need to just ask the people or something.
I'll try to follow up with Adam either tomorrow or on Monday if he's had any progress in looking at that stuff.
Yeah. Okay.
The other thing that would be really useful to get is fragmentation information, right? How fragmented has memory become? Because we don't even know that yet. We suspect, but
yeah. Okay. Well, unless we can get sort of meaningful numbers out, I think as a stopgap, we just need to like hard code like 70% or whatever we think sort of is.
Yeah.
It's clearly not 100%.
Yeah. I also want to design an interface for this that can very reasonably take into account scaling factors for different things, right? Like when we assign priorities, if allocating 50 megabytes to something really results in a 80 megabyte allocation, whereas for something else, if allocating 50 megabytes results in a 55 megabyte allocation, the priority based mechanism for dealing with this stuff should be able to kind of take that into account when assigning memory for different things.
If we
Of
know
what
what
it
the
actually
overhead
is.
of different pools are, you mean?
Yeah, like, if we're saying that that O nodes should get a 50% allocation and KV should get a 40% allocation, take into effect what it really is going to use as opposed to what the mempool thinks it's going to use.
Yeah.
So I want to make sure that that's kind of it's reasonably done and not just kind of like hacked in after the fact for that. So I'm going to try to think about that a little bit too.
Okay.
Hey Sage, I'm
Yep.
just looking at our perf glue, but the heat pro or the stats that we have, I don't think actually require the heat profiler to be running. Like the
Okay,
human
this is in,
readable.
yeah, this is in perfglue.
CC, yeah.
Where is
Do you
that?
have a link quick, Greg?
What's the file name again?
Ceph source perf glue / heat profiler.
There it is. Okay, and what stats
And
do we get
there's
out of
also a
this?
get numeric property one there. And
Okay, and they don't actually require that to be turned on.
I don't think it should. I'm just looking at this and maybe they already turned 0, but I think it's just available.
Okay, so maybe that'll just work. That'd be nice.
Yeah.
Sorry, it was heap or perf glue and what file? Heap profiler?
Heat profiler.cc. Yeah.
Sorry.
Okay.
It up.
Let's see.
Source.
This is like bin ceph daemon. How to recompile.
Is it the heap profiler dump call? Is that what we're looking at?
Yeah.
So if I just call stats.
So that's the human readable one, I think.
Because it has a check in here that it'll refuse to let you do the dump command if it's not running.
So the stats one isn't though.
Ah, got it. Okay. Got it.
Yeah.
Okay.
And maybe that's just broken, but it's very careful to separate that. So I think it just works.
Cool. Okay.
And that should be the like what's allocated, what's allocated from the system but not allocated by the program, etc.
All right. I'm doing.
Sage, that malloc extension you were looking at when you were looking at like last week or whatever?
Yep. Yep. What about it? Did I just cut out or didn't Mark?
I think we lost Mark.
Okay. How do I do the heap profiler? Oh, it's not.
No.
My source trees I compiled without malloc, so I could run Valgrind.
Testing. 1, 2, 3, testing.
We can hear you now.
Oh, you can. Oh, fantastic. I jiggled the USB plug, so apparently that was the fix. Well, I found an old PR saying that tcmalloc getstats was not showing the correct data.
I know it works under many cases. I'm not going to guarantee it's never been buggy.
Yeah,
But let's start with that.
sounds good.
You really ought those numbers are numbers you really ought to be able to get without having a heat profiler running. That's stuff the allocator needs.
Yeah.
Yeah.
OSX memory stats wildly different from tcmalloc report.
Okay.
Oh.
Well, it sounds like that's the next step. Well, I think we just want to get Mark's pull request tested and merged.
Yep.
And then on top of that, add in something that looks at these tcmalloc stats, and based on the disparity between what it has claimed from the OS and what it's actually allocated, say there's a 30% difference, it'll scale the blue store cache size, whatever, according based on that. I think that's what we want.
Yep.
I think the only question is if it's above some threshold and we haven't done it in a while, should we do like the automatically do the tcmalloc heap free whatever thing? I know that we used to do that in like production situations where memory got out of control and we would have to like poke it, and then that sort of seems to not be necessary in newer versions of tcmalloc. But I never was involved in those support cases. Do you remember this, Greg?
I do remember it. I think it was just there were various buggy versions of tcmalloc packaged in distribution, so that made it better. I don't think it was a.
Okay. So should we ignore that then, or do you think there's a case where we should?
And if you want to write the logic, then go for it. I hope it doesn't turn up.
Yeah, well, I wouldn't know what the threshold would be, I guess.
Yeah, that's
like,
that's
is it above 20%? Then we do it, and we only do it once a minute. I don't know, whatever.
Yeah, I mean, like 20%, I think has been a lot all the time. Although maybe you need to put a minimum size on there too. Like if it's 20% and the total memory usage is 200 megs, then we don't care. But
yeah.
I mean, all the samples I've seen lately were much lower than that. So.
I did a test recently with the RGW case, which was where the OSD was using the most memory, and in that case it was about 10%. It was like 6.5 or 7 gigs of OSS RSS memory usage, or OSD RSS memory usage, and it was like 600 megabytes of memory that could be freed back to the OS.
Okay. That's not so bad.
We could.
Yeah. We can.
One thing that I want to do is add like PG log memory that's pinned into the pinned memory in the cache balancer. So kind of start including things like that. Like some of the memory that's allocated is going to be reserved for PG log, or it's going to be reserved like for other things. Like right now, one of the things that gets reserved is memory for indexes and filters in RocksDB.
Mm-hmm.
So there's kind of this priority 0 level of reserved space for things. And if we can't hit it, then we actually assert right now initially by saying, we can't support this. It doesn't for RocksDB's indexes and filters. At that point, it will try to, but it won't successfully. It won't fail if it doesn't reserve those. But for things up front that it knows about, it will say, I want to reserve space for this, and if I can't, then fail. And that's like the logs we probably do, because right now we require those logs to be in memory, right?
Yeah. Yep.
So it might make sense that if we say the user specifies, I can only have 1 gig of memory for the OSD, and they specify enough PGs per OSD that they're going to exceed that up front, we might actually, in that case, want to assert and tell them, you don't have enough memory assigned to do this.
Or do something to tell them. Yeah.
Yep.
Unclear what that would be. Okay. Okay. Anything else you should talk about?
I've just got one small thing.
Yep. How's it going?
Was there any sort of change in the locking during scrubbing between dual and luminous? Only asking because I've upgraded a cluster to luminous, and when I've got deep scrubbing going on now, sort of a Rados bench where I was getting about a 1 or 2 millisecond average write latency, I'm now seeing it in the sort of 30 millisecond range. Putting in scrub sleeps and stuff like that seems to help bring it down, but it's almost like when a deep scrub is going on a PG, all sort of fairly IO just gets held up by the locks, which didn't happen in dual as far as I can see.
I don't think we changed the locking, but what might have changed is some of the, you might have tuned options in Joule that no longer exist in Luminous that were replaced by a new sleep. I wonder if that might have been what the difference is.
I don't think I had. I think it was a pretty standard config.
Do you know which lock or which locks are involved?
I haven't managed to look into it that deeply yet. It was just sort of one of the last clusters I upgraded to Luminous, which is where we've got sort of probably the most monitoring on. I just suddenly saw we've got a collect D job which just does a Rados bench every 60 seconds, and suddenly noticed that went from sort of sitting about 1 millisecond up to about 30 post upgrade. And if I run, sorry.
Only when deep scrub is running?
Yeah, so if I do, it might also be normal scrub. I don't think it had as large effect, but it was still there. But if I run like a FIO on a RBD and I did 4K sequential writes, so it's spending a lot of time per PG effectively. You would see when it hits one of the affected PGs, suddenly it would just go to almost like 0 IO for a couple of seconds, and then as it sort of gets to the next one over, it then spikes back up.
It's possible we changed something, but it should. If we changed something, it would have been only when the scrub window intersects with an actual object that you're writing, and that wouldn't happen very frequently at all, like with the Rados bench. So
yeah, and I thought that basically all of the scrub stuff was this like because we fixed it in Joule, but I think all the fixes were like I think the Luminous version and the fixed Joule version were basically the same, unless there were more things that went in Luminous after initial release.
yeah, there's a majorish change that happened after Luminous for Mimic, where if you're scrubbing an object and an IO comes along, instead of the IO waiting for the scrub to finish, the IO will preempt scrub, and the scrub will get repeated after, which should have a significantly reduced latency. But we didn't actually backport that to Luminous, so I'd be kind of curious what you would see if you went to Mimic on that cluster. But since you just went to Luminous, that's probably not going to be for a while.
Yeah, I mean, I can probably replicate this on one of the other Luminous ones, which is going to be more of a candidate to go to Mimic at an earlier date, and see if that helps when that happens. Yeah.
Okay.
Nick, go ahead.
There's I think you can do clear historic ops on an OSD, and then maybe do at the bench and get some of those 30 millisecond writes, and then dump them. There might be a clue in the dump historic ops, which will show basically your sort of long tail request, whatever. That might tell us something.
Okay.
Nick, in addition to that, it may be worth trying either the GDB wall clock profiler that I've got or Adam's wall clock profiler, the C++ version. His version actually will slow down the OSD far less than mine will, but that might give you a clue as to where time is being spent, even kind of what lock potentially might be contended on.
Okay.
And where. So it if you use the GDB version that I've got, it will slow your cluster way down.
It's not going to be sitting on an actual lock, though. It'll be some throttle limit somewhere. I'm pretty sure.
One way or another, though, if it's something that shows up, we should be able to pinpoint it with either Adam's or my profiler probably. If it's spending a lot of time in one particular area of the code.
Okay. I mean, I assume from a very high level, what's happening is this cluster's sort of 7.2K disk is that it's probably trying to read like a size of data in the scrub, I know maybe 4 meg or something, which is probably taking 40, 50 milliseconds, and that's just basically holding all the I/O up until that goes through. I don't know why that would be any different to what Jill was doing, but
that might be it. At some point, we changed it so that we hold the lock during the actual read operation. I wonder if that's what the difference is.
Sage, which lock are we holding during the read operation?
The PG lock.
PG lock, okay.
Was it running the latest Joule?
it might have been about 0.8 or 0.9. I can't quite remember now.
Joule was 10.2.0, is that right?
Yeah.
Yeah, I can't remember when we made that change. I remember changing that a year or two ago. It was just not safe, basically. So.
Yeah, I mean, it sounds like probably what it's doing now would be the correct, what you would expect it to be doing, that you wouldn't want the data possibly changing in that PG whilst it's checking it. I guess the only problem is that depending on the amount of data you read, you're going to effectively lock the head up on the disk for that amount of time.
Yep.
So I mean, I don't know if playing with like the scrubbing stride size, so it's trying to read smaller chunks of data at a time, so that the scheduler can sort of try and insert data sort of I/O in between the various scrub reads would help. That's probably something I need to experiment with.
Yeah. Okay. Yeah, I don't have a good answer. I'm guessing that that's some variation of that is what's happened, and that Mimic should mitigate it by preempting that, letting you preempt those operations. But I think I don't know. Yeah, if you can reproduce on another environment that we can play with, that would be helpful.
Okay.
Yeah. Okay. All right.
Question I have for folks, if anyone who's played with RocksDB a lot, has anyone ever tried to change the buffer size of RocksDB's write-ahead log during operation? Like, has anyone ever tried to change it at runtime? I'm guessing the answer is no, but if anyone has.
Mm-hmm.
Nope. Okay. I might be the first to try it then. Thank you.
Yep. All right. Are we done?
I think we're done.
Cool. All right. Thanks, everyone.
Have a good week, guys.
See ya.
Thank you.